Okay, welcome to my CCNA study guide for Chapter 5. We're talking about VLSM, variable length subnet masks, summarization, and troubleshooting basic TCP/IP when it comes to addressing. Okay, keep in mind this is a very short, quick, straight to the point summarization on VLSM and summarization. If you want a more in-depth one, view my other playlists for VLSM and IPv4 basics. Alright, so the point of this chapter is dealing with addressing and troubleshooting. So here's a typical classful network. Well, we said classful, so why is everything /28? Because even if we don't need our X amount of hosts, /28, so 25, 26, 27, 28, that's in the 16 spot. Each of these will be groups of 16. So that actually will not work here. Let's double check. 25, 26, 27, 28. 1, 2, 4, 8, 16. So yeah, that does not work here at all. Also, we need 2 hosts, and we're giving them 16, 14 usable. So here we're wasting 12 addresses. So that's one of the problems with with classful networks is we start wasting hosts. With a classless design, we can actually change the subnet mask. That way we're not wasting hosts here. We need 2 usable, we have 2 usable. Here we have 25 hosts. We may need /27 should be a 32. So we have 32 usable. So here we're only wasting 5 addresses. A lot better than not being able to use it before. So essentially, how we look at this is if you take the slash number, that's how many ones you have. Let's assume we're working in the 4th octet. So that means the first 3 are already full of ones. 1, 2. So that means there's already 24 ones. For that /25, we start with 1, we double 2. So if you start with 1 and you just keep doubling it, so 1, 2, 4, 8, 16, 32, 64, 128, you circle the 1 position, that's the 128 position. That means your mask will be 128, but your groups will be 128 also. If it's a /26, that means the first 2 ones, we're taking the last one on the right-hand side, and whatever position that's in, that's our grouping size. Again, for more details, visit my variable length subnet mask videos. So again, here's a VLSM network example. You'll notice each network is tied different subnet masks based off of their need. We have /30. That way we can guarantee that we're getting just the appropriate services that we need. Again, example 2, if we need 2 hosts, we're doing normally a /30. If we need 60 hosts, again, we can use that same chart. 60. So let's assume there's already 24 ones over here. So if we need something with 64 hosts, both of those have to be in there, so that should be a /26. If we're looking for 16, again 24, 25, 26, 27, 28, so that'll be a /28. That'll be a /26. For that 60, again, we're looking for the second number, it'll be a /26. For this 8 usable, we can't, this is going to be 8 total, so we need to go to that 16. So 24, 25, 26, 27, 28. That'll be a slash 28. For that 12, we're looking again for that 16, so 24, 25, 26, 27, 28. For the 12 hosts, again, slash 28. For 30, we can get away with this guy right here. So 24, 25, 26, 27. And there we go. So how do we do summarization addresses? So essentially, we can, the dumbed down version is what is the most common. Here we have 10. So we lock in the first 8 bits. So 10,000 with the first 8 bits locked in. You normally can break this down into binary. Is going to be the common one. The summarization. If we want to summarize all of these, we could summarize them, assuming they are close to that, we can summarize them to that. That one didn't quite yield the most information. Here you're going to notice that we have, what's the most common out of all of these? You have to pay attention to all of the octets. 172, 17. Or sorry, 172.1. The slash 16. That is one quick way to do that. We could go more in depth because again, we have a 4, a 5, a 6, a 7. So I mean, we could see if we could do anything that third octet, but again, we're looking for the common between all of them. So 172.1.0.0 slash 16. That works because that means that locks in the first 2 octets. And the first 2 for all of them are 172.1. So that works. So basic IP troubleshooting normally goes back to you start pinging slowly. So if Sally wants to ping server, we could ping all the way through. But if that doesn't work, maybe try pinging that interface right there on the router, or that one, or maybe assume maybe our switches have an IP, or maybe a PC on our network. So we slowly, systematically go through our network, seeing what resources available. So 4 common steps for troubleshooting is open a command prompt, first ping yourself, then ping your IP address, ping your gateway, and then ping an external resource. And that's this chapter in a nutshell. Thank you.